students, and welcome to our final STEM project of the year. And back by popular demand is the Man in the Moon. Yeah, he's here to join us in our project for the day. Now, as you remember from the last time we met, our STEM project this week is going to be a little bit different throughout the entire week. We are going to be working toward a big goal come Friday. And in order to achieve that goal, we're breaking it up into smaller chunks. And so today, we've got a fun little contest for you to compete in. And remember, there are prizes for the winner of today's competition. Now, what is it that we're going to be making today? Well, we're going to be making the Mr. Skirpst blaster rocket. No, not the Mr. Skirpst one, because you're all going to be making your very own rocket blaster today. But the end product will look something like this. But of course, yours will look much better than mine. But essentially, the rocket blaster is made up of a bottle, which is going to be our stomp blaster, a straw through the cap, and our rocket, our paper rocket that we are going to be constructing today using the template that I am providing you and some basic materials, including a pair of scissors, a pencil, and some tape. Now, for those of you that are remote, I have included a JPEG image attached to the Google Classroom that when you print it out will look like this. For everyone in person, I'll be giving you your very own copy, and we'll be talking about this copy in just a little while. But these are all the materials you need in order to make your rocket blaster, which we will be using at the end of the period to launch toward a target. Because remember from last time we met, our objective today is accuracy. We want to construct a rocket that will fly as accurately as possible. So, without further ado, let's get started with our project for today. Now, as we do prepare for this project, I want to ask you some questions real quick. How many of you remember any of the variables that we talked about last time? Some of the variables, some of the things that we can change with our rocket. So pause me now and discuss some of the variables. Great. Hopefully you mentioned some things like the length of the fuselage. And in our template, I'm giving you 3 options to choose from. The long 15 centimeter fuselage, the short 5 centimeter long fuselage, or the medium length 10 centimeter fuselage. Some of the other variables that we discussed included the fin size and shape as well. So I'm giving you some templates here, some larger fin templates and some smaller fin templates, and some different shapes from the triangular to the rounded to the blunt end. And you actually have 3 smaller ones here that you can experiment with yourself and come up with your own shapes and your own sizes for that matter. So there are a number of variables that you're going to be altering today in order to construct your rocket, which again, the goal is to achieve the greatest accuracy. So let me take you through the steps quickly now so that you have the rest of the time to assemble your rocket. So let's begin. You all have your template in front of you by now. The very top part of the template, it has a little message on it: do not share launch bottles. Remember, in our time of special circumstances here this year, We're trying to minimize the sharing of any equipment and certainly minimizing any exposure to any germs that might come out of your mouth. So when we create our rocket blasters, they are yours and yours alone to keep. That's right. We're not going to share these blasters, and you'll see why when we get to the project itself, but you're going to be able to keep these. But before we even get started, I have to have you promise me, please, promise me that these will only be used in science class and at home under safe conditions. Please do not let me find out that you're using these during the rest of the day, because I don't want you getting into trouble, and I certainly don't want anyone getting hurt with the rocket blasters. So please promise me that. In fact, raise your right hand right now and say, Mr. Skirpst, I promise not to use the rocket blaster anywhere but science class or at home. And I also promise to always be safe. All right, now that you've made that promise, now let's have some fun. So, the first part I want you to remove is this big rectangular area up top. And when you cut along the solid line on your template, this is what you will be removing. So here it is. And on this paper, I want you to write your name and come up with a name for your rocket. Okay? Once you've done that, you're going to take a piece of tape, and you are simply going to tape it around your bottle like this, like I've done here. Just tape it along the back so that everybody can see that this is your rocket blaster and nobody else's. So we don't share rocket blasters because they may be filled with some of your germs. So we only use your own rocket blaster and keep the label on at all times. Yeah, it's gonna get squished up, but that's okay. It'll stay on the bottle if you tape it really nicely. All right, so that's the first thing. Next, what you're going to do is you're gonna decide upon one of the fuselages. And by the way, does anyone remember what fuselage means in French? That's right, ooh la la, body. Fuselage means body. So when you're going to determine what body for the rocket to choose here, you are selecting the fuselage. I have simply chosen the longest one because it's the first one that I came to when I started cutting out, but you choose the one that you think is going to provide you the most accurate rocket. But you'll notice you're going to cut along the solid lines, cut out whichever one you want. And you're going to be experimenting here throughout the period and throughout the week. So don't destroy the other templates. You may use those at a later point. But I have selected the 15 centimeter fuselage body of the rocket to begin with. Let me just demonstrate quickly how you're going to create your fuselage. You need your pencil and you need some tape, because what you're going to do is place the pencil over the paper lengthwise like this. And then you're simply going to roll the fuselage around the pencil, just like this. Pretty easy, right? And I'll hold it so you can see it's the 15 centimeter fuselage. Now you got to pinch it, hold it nice and tight, as close to the pencil as you can, so that when you're holding it there with one hand, you can reach for the tape with the other hand and start taping the fuselage together. You want to make it tight around the pencil, but not too tight. Don't tape it to the pencil, but you are taping the fuselage template to the pencil like this. And remember, you want to make it airtight. So be sure to use enough tape to seal the seam. But here we have my 15 centimeter fuselage, and you should be able to remove the pencil. But while we're creating your rocket, keep the fuselage on the pencil. It'll make the next step easier, because the next step will be to cut out your choice of fins. Now I'm selecting the bottom left-hand corner, the large triangular fins. So remember, you cut out the whole square. You cut out the whole square like this, and then you cut along the solid lines so you have two triangular shapes. And notice the dotted lines on the triangles. And if you recall from the video on Friday, we fold along those dotted lines, and I'm going to fold along the outside dotted lines, and I'll show you here in just a moment, so that my fin looks like this. See how I have it? I folded along the two outside dotted lines. I'll do the same thing here so you can see. Fold inward along the dotted lines, the outside dotted lines, so that you've got two fins shaped like this. Because what you're going to do now is grab some tape. You're going to tape it along the top of the fin, and then you're going to place it at the end of your fuselage like this. And then we'll put another piece of tape on the bottom, and then we're going to do the same thing to the other fin. So let me get this taped in here first. So again, you're taping along the center line of your triangle that you've cut out, and the other dotted lines are where you're going to be folding your fins outward. Now, you're going to do a better job than me because I'm doing this while looking in the camera. But this is what you're going to do with the one triangle. And now we're going to do the exact same thing with the other triangle on the opposite side of the fuselage. So we're going to put our tape on the fins. We're going to tape it to the other side of the fuselage. And make sure that you don't have any excess tape coming off the end. If you do, just rip it off. You can get rid of the tape or use it somewhere else. So tape the fins, and then you're going to be bending the fins. Pretty much you're going to bend them all at 45-degree angles so that when you get done with them, all of the fins should be approximately perpendicular to one another and look like this. Now, if you were paying attention last week, some of you may remember the secret tip that I gave you for accuracy, but you had to be paying attention last Friday to get that correct. Now, we're almost done with your rocket. At this time, you can remove it from the pencil, and we have to pinch the nose of your rocket so no air escapes out of the top of the rocket. So we use another piece of tape here. And remember some of the variables we discussed, like the type and the amount of tape was one variable. So once we pinch that closed, your rocket is pretty much complete. You're finished with your first prototype of your rocket. Remember, if you're not pleased with its performance, you're going to engineer different ways of improving the design of your rocket. But let me show you how we're going to launch your rocket. We'll make sure that your cap and straw is securely connected to your blaster. Your rocket is on the top of the straw, and make sure that your rocket can easily slide up and down on the straw itself to minimize friction. And now you're ready to go. What you will do one at a time, and Mr. Skirps will give you instructions on how to do this. Do not launch your rocket until everyone is in a safe position. There is a target that will be provided to you to shoot toward, and you're going to be shooting at that target from a designated distance. So we'll do this one person at a time. You'll come to the launch pad before you launch your rocket toward the target. But when you're ready, here's what you do. You're going to take your blaster in your hands, both hands, like this. You're going to aim your rocket at whatever angle, altitude you want to aim it in, whatever direction. Again, some variables for you to experiment with. And when you think you've got it just right, you're going to squeeze the bottle and... Whoa! My goodness! I just shot my rocket all the way across the room to the opposite side. Wow, that was really fun and really cool. I'm excited that you're going to have the opportunity to do this yourself in just a moment, but remember, we want to be safe. Boy, this is really cool. Now, as far as your blaster is concerned, it's all squished right now. So how do we reinflate it for our next flight? We want to recycle them. Well, you've got the straw at the top. Just puff a little air into the bottle, and now you're ready for launch number 2. I just so happen to have another rocket here. Oh, yeah, baby! All right, so, and by the way, we're always going to announce our launch by saying 3, 2, 1, launch! Woo! That one went farther than the first one. Wow, that is so cool. And to get ready for the next launch, reinflate the blaster. And that's why we're not sharing the blasters. Because you put your mouth on the straw, you put your germs in there. They are your germs. You may keep them. No need to share. All right? So that is our rocket blaster experiment for today. Shouldn't take too long for you to complete the rocket. Then we'll have some fun launching them toward the target. And say, if we need more time to experiment with the variables, we're going to continue this tomorrow as well. Remember, as we work toward the greater project for Friday. So I hope you have fun with this first part of our final STEM project. And so until next time, I'm going to say bye-bye.